Hello guys, welcome to my YouTube channel Physics Springs. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My course is going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physics. So this is the lecture number 3 of mathematical physics. Okay, so before starting the class, I would thank you everyone who subscribed my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. Okay, so I'm continuing the class. The last time I was solving uh, net questions, but that time there was a issue in microphone, and because of that I had to end the class. So now I'm going to continue from there. Okay, so we are studying vector analysis. This is the lecture number 3. So I'm solving the question, which is question number 1. There was a sound issue, there was microphone issue last time, so I'm solving this question again. Okay, so this is the question number 1. Okay, which is asked in CSIR NET June 2012. CSIR NET June 2012. Okay, this is the question. Okay, so question is, a vector perpendicular to any vector, a vector perpendicular to any vector, a vector perpendicular to any vector that lies on the plane defined by x plus y plus z equal to 5 is. Okay, options are I cap plus j cap. Option B is j cap plus k cap. Option C is I cap plus j cap plus k cap. Okay, and option D is 2 I cap plus 3 j cap plus 5 k cap. Okay, this is the question. Again there is a sound issue, so just let me check it. I'm just checking, guys, just give me 1 minute. Hello, I'm just checking, guys, just give me 1 minute. Hello. I I think sound is correct. There is no issue in the sound, I believe. Okay. Okay. The question is a vector perpendicular to any vector that lies on the plane defined by this. So we need to find out a vector which is perpendicular to plane this. Okay. That we need to find. So in last class we have already studied the gradient, right, and the physical significance of gradient that we have studied. So we'll use that and solve this question. Okay. So gradient of phi, the physical meaning of it is the perpendicular to the level surface or plane. So that is the gradient of phi, right? So phi is given, that is x plus y plus z minus 5. So this is the phi which is given. So this is the equation of plane. Okay. And this one, right, this is a plane and this is the equation, and we have to find perpendicular vector, right, and that is gradient of phi. Phi is given, that is x plus y plus z minus 5. Okay. So it's easy one. So now what we are going to do is we are going to uh, solve it, right? Okay. Okay, Rakesh, I will do it. Rakesh, I wanted to ask you, am I audible? Just please confirm me. Yeah, last time I taught vector that the gradient, right? Check my last class. At the moment, I'm solving PYQs of IIT-Jam, NET and GATE. Okay. Could you please confirm, Rakesh? Am I audible? Okay. Thank you, Rakesh. So I'm continuing. So this is a question which is asked in CSIR NET June 2012. Very simple question. Please check my last class. That time I had to disconnect the class because there was an issue in microphone. Okay, so I'm continuing the same class. Uh, this is the question from where there was a microphone issue. So I'm solving this question again. Okay, it's a very simple question. I would request you please watch my last class. Okay, so a vector perpendicular to any vector that lies on the plane by x plus y plus z equal to 5 is, that's what we need to find. So I'm going to explain for you it again. So gradient of 5 means the vector which is perpendicular to any level surface. Okay, so this is a plane which is a level surface, is a surface, and gradient of phi is perpendicular vector, right? So we have to find a vector perpendicular vector to any vector that lies on the plane. So any vector, so suppose we can take this vector is any vector, this is lying in the plane, this plane, right, this plane. Okay, this angle is 90. So perpendicular vector on any surface, so this is on the surface, right, that is called gradient of phi. Perpendicular vector on the level surface or any plane. Okay, or so this vector is on the plane, right? So if this vector is perpendicular to this vector, that means this vector is also perpendicular to this plane. So perpendicular vector, right? Level surface is given here, means equation of uh, plane is given. Okay, so this means gradient of phi is going to be, we'll write, so we know the value of del, right? This is del upon del x I cap plus del upon del y j cap plus del upon del z k cap. Okay, and phi, We will write the value of phi. This is x plus y plus z minus 5. Okay, we'll solve it. So we'll solve it now. I'm going on next page. So we know the how to solve gradient, right? We'll operate this with this first. Okay, so we can see that this is x, right? We have to differentiate this phi with respect to x, means we'll take only this term, these terms are constant for this, right? So this is going to be gradient of phi, that is perpendicular vector on the plane. Okay, so that is going to be uh, I cap plus j cap, I cap plus j cap plus k cap. How? Because we have differentiate x with this value will give 1. 1 into I is I. Similarly, will operate this one with this. So with respect to y, this value is going to give 1, 1 into j cap, and similarly with z, right? So it is going to be gradient of phi equal to I cap. Definitely get one question of 3.5 marks in net and gate as well, and also in jam. So I'm going to solve all those questions, the questions related to gradient of phi, okay, which are asked in jam, gate and net. So now we are going to solve question number 2. Okay, okay, so next question number 2, which is also this: a unit normal vector, the unit the unit the unit normal vector the unit normal vector of the point a by root 3, comma b by root 3, comma c by root 3 on the surface on the on the surface surface of the surface of the ellipsoid surface of the ellipsoid x square upon a square plus y square upon b square plus z square upon c square equal to 1 is. Okay, options are given: bc I cap plus ca j cap plus ab k cap upon root a square plus b square plus c square. Option B is ai cap plus bj cap plus ck cap root a square plus b square plus c square. Option C is bi cap plus cj cap plus ak cap upon root a square plus b square plus c square. Okay, and option D is I cap plus j cap plus k cap, I cap plus j cap plus k cap upon root 3. Okay, so this is the question, the unit normal vector of, okay, this question is asked in CSIR net December 2012 question. Okay, December 2012 question. Okay, so the unit normal vector of the point, there's a you need to find out unit normal vector at point a by root 3, b by root 3 and c by root 3. Okay, on the surface of ellipsoid. So ellipsoid surface is given. Okay, so phi is given, and also I would like to tell you that these options in this question, these four options are incorrect. Okay, none option is the correct one. Okay, so I will solve it and I will solve it, and then you will see the exact answer which is not given here. These four options are incorrect in this question which is asked in uh, December 2012. Okay, so this is going to be, okay, so it, so phi is given, that is ellipsoid. Okay, so this is x square upon a square, x square upon a square plus y square upon b square plus z square upon c square equal to 1. This is given. Okay, so this is the level surface which is given, right, ellipsoid, and we have to find out a unit normal vector. Unit normal vector. Okay, this is straight line. My hands are not set on pen tab. This is unit normal vector. Okay, and you can suppose this is the ellipsoid. Okay, ellipsoidal surface, and this is the vector, unit normal vector. Okay, which we and and this is at point this a by root 3, b by root 3, c by root 3. Okay, these are point a by root 3, b by root 3 and c by root 3. Okay, so ellipsoid equation is given, that is phi is given, right? Okay, so now we know the formula for unit normal vector, that is n cap that is gradient of phi, okay, upon mod gradient of phi. Okay, gradient of phi mod. Okay, mod of gradient of phi, right? So this is the normal vector on level surface. Okay, uh, okay, if it is just an vector, if it is asked at just normal to the surface of ellipsoid, then this would be gradient of phi. But it is asking normal unit vector, right? Then this is going to be gradient of phi upon mod of gradient of phi. Okay, okay, so n cap is going to be, so we'll first we'll find this one, gradient of phi, one by one. Okay, calculation is lengthy, so we'll find gradient of phi first, then we'll put the value in equation 1. So it is gradient of phi is going to be del over del x I cap plus del over del y j cap plus del over del z k cap I cap plus j cap plus k cap into phi. Phi is going to be this one, x square upon a square plus y square upon b square plus z square upon c square minus 1. Okay. This is minus 1. Okay. So this is going to be gradient of phi. This is going to be gradient of phi. This is going to be will operate this with this. So this is going to be 2x upon a square, 2x upon a square I cap plus 2y, we are differentiating, right? 2y upon b square j cap plus 2z upon c square k cap. Okay. So it is going to be gradient of phi. Okay, gradient of phi. Now we'll find out gradient of phi. Here the gradient of phi, this is at point, right? This the point which are given, that is a by root 3, b by root 3 and c by root 3. Okay. Okay, so gradient of phi is going to be gradient of phi at a by root 3 point. Okay, at a by root 3 comma b by root 3 comma c by root 3. Okay, this is going to be equal to, we'll put the value, okay, in xy, in the air, in place of x y z, we'll put the value of those points which are given. Okay, so it is going to be 2 upon a root 3 I cap. A get cancelled. Okay, that's why it is a remaining, and this is going to be 2 upon b root 3 j cap and plus 2 upon c root 3 k cap. Okay. The best part is, if I'm first my what I'm going to do in mathematical physics is, I will teach you topic first, and after that I will solve questions related to that topic, and those questions will be from IIT-Jam, GATE and NET exam. Okay, so that you can easily solve questions. So this is a NET question which I'm solving. After that I'll solve GATE and then questions from the JAM, IIT-Jam related to the same topic, so that it will be more clearer, and you can because these questions are very important questions, and you will get in NET exam. So this 3.5 marks questions are these. Okay. Okay. Well, so this is the value. Okay, this is the value of gradient phi. Now we'll find out mod of gradient phi. So this is going to be, we have to find mod, right? So this is going to this mod, it is 4 upon a square into 3 root plus 4 upon, we can write 3b square plus 4 upon 3c square, okay, because square of root 3 is 3. Now what we are going to do, this is the 1, and then we will find n cap, that is normal vector. That is from equation 1. This is the equation 1, okay. We'll put the value here. This is going to be gradient of phi at this point is 2 upon a root 3 I cap plus 2 upon b root 3 j cap plus 2 upon c root 3 k cap upon mod of gradient phi, okay. So this is going to be, so we can take 2 outside and root 3 outside, so it is going to be 2 upon root 3 outside will take, and this is going to be root first we'll write as it is, okay. So it is going to be 2 upon a square plus 2 is 1 upon a square, sorry. This is calculation part, and 1 upon b square plus 1 upon c square, okay. This is the 1. So n cap is going to be, you can write as 2 upon root 3 a I cap plus 2 upon root 3 b j cap plus 2 upon root 3 c k cap upon, we have taken 2 root 3 common, right, and this is going to be, we'll take LCM, a square b square into c square. It is going to be root a square b square c square, we have taken LCM here, and then it is going to be b square c square c square plus a square c square plus sorry, a square b square plus, yeah, a square c square plus a square b square, okay. This is c square, okay. So 2 by root 3 will get cancelled, right. So it is going to be and ABC will go up and AVA will get cancelled, so it is going to be BC I cap plus CA J cap plus AB K cap upon root B square C square plus A square C square plus A square B square, okay. This is the answer, this is the correct answer, okay. But in this question no option is matching, okay. These all options are incorrect, and correct option is this is the one. I hope guys you understood it. So very simple question, and this is 3-point mark question in CSIR NET exam, okay. So next question is from CSIR net again. Okay. These are questions related to gradient. Okay, gradient of phi. Okay, let me just get the question. System is slow. I got the question now. This is the question number 3rd. Okay, this is also very good question. Question number 3rd. Okay, and this is also asked. This is CSIR net question, which is asked in December 2014. December 2014. Okay, I'm teaching you. I'm solving the question related to the topic which I have already taught. Okay. Okay. So question number 3rd is, this is, let R denote, very simple question, let R denote the position vector of any point in 3 dimension three-dimensional space and mod R equal to R, then options are given: divergence of R equal to 0 and curl of R equal to R vector upon R, that is mod R. Option B is divergence of R equal to 0 and gradient, that is del square R equal to 0. Option C is divergence of R equal to 3. Just give me 1 second, okay? There is some, I need to fix it. Okay, it is fixed now. So divergence of R equal to 3, and del square R, that is Laplace square R vector, equal to R vector upon R square, and option D is divergence of R equal to 3 and curl of R equal to 0. Okay, so this is the question. Let R denote the position vector of any point in three-dimensional space. R is a position vector which is given, and mod R equal to R. Then which option is correct? Okay, divergence of R equal to 0 is 0 actually. 0 or divergence of R equal to vector R upon R. These are the options which are given. Okay, so we have to find which option is correct. Okay, so we know position vector R, that is equal to x I cap plus plus y j cap plus z k cap. Okay, so this is the one. This is the R vector. So what we are going to do is we'll find divergence of R, that is del upon del x I cap plus del upon del y j cap plus del upon del z k cap into R. R is x I cap plus y j cap plus z k cap. Okay, so we'll solve it. So this is going to be, we'll operate this with this, and this is going to give this one, x into x, right? Del x. So it is going to be divergence of R is going to be 1 plus 1 plus 1, that is 3. Okay, so divergence of R is 3. It means which option is matching? So obviously it may be C option or D option, right? Now we'll find curl of R. Now curl of R will find, we know I cap, j cap, k cap. This is del over del x, because R is x I cap plus y j cap plus z k cap. Okay, del over del y, del over del z into x y z. So we'll solve it. Okay, so this is going to be I cap into this one, okay, del z of del y and del y of del z. So this is going to be 0. So not 0 actually. So I cap, this is going to be del z over del y minus del y over del z minus j cap. It is going to be del z over del x minus del x over del z plus j cap plus k cap. It is going to be del y over del x minus del x upon del y. Okay, so if you open it, this is going to be 0. Okay, so curl of R is 0, divergence of R is 3 and curl of R is 0. So which option is matching? Option number D is matching. Okay, so option D is the correct answer. Okay, next question is gate question. Okay, so let me just check it. Question number 4. Question number 4. This is the unit normal vector. The unit vector normal to the surface, normal to the surface, x square plus y square minus z equal to 1 at point p equal to 1 comma 1 comma 1 is. Okay, this is the question which is asked in, it's a gate question. Two 2011 gate question. Okay, so it's gate question, gate 2011 it is asked in. Okay, options are I cap plus j cap, I cap plus j cap minus k cap upon root 3. Option B is 2 I cap j cap minus k cap upon root 3 root 6. Option C is I cap plus 2 j cap minus k cap upon root 3, sorry, upon root 6. And option D is 2I cap plus 2j cap minus k cap upon 3. Okay, so these are the options which are given. Write it correctly. Two I cap plus 2j cap minus k cap minus k cap upon 3. Okay, these are the options which are given. The question is the unit vector normal to the surface. Surface is given, normal to the unit vector normal to the surface is given at point 111 is. Okay, so unit normal vector. Okay, so we are going to solve it. I'll solve the next page. So we have been given, that is equation of surface is given. This is phi equal to x square plus y square minus z. X square plus y square minus z minus 1. Okay, so this is the equation is given. Okay, so now we need to find unit vector. We can easily find out. First we will find gradient of phi. Gradient of phi is going to be del over del x I cap plus del over del y j cap plus del over del z k cap into x square plus y square minus z minus 1. So this is going to be 2x I cap plus 2y j cap minus k cap. Okay, this is the one. So now we'll find gradient of phi at 1 1. Okay, so at point 111, so it is going to be we'll replace 111 from xyz. So we will replace xyz from 111. Okay, so 2 into 1 I cap plus 2 into 1 j cap minus k cap. So it is going to be 2 I cap plus 2 I cap plus 2 j cap minus k cap. Okay, okay, so now we'll find out normal vector, that is unit normal vector, that is going to be gradient of phi upon mod gradient of phi at 111 point. Okay, so this is going to be equal to 2 I cap plus 2 j cap minus k cap, and this the mod of this, right? Mod of this, and this is going to be 4 plus 4 plus 1. Okay, okay, so it is going to be 2 I cap plus 2 j cap minus k cap upon, this is 9, root of 9 is root 9, value of root 9 is 3. This is the answer. So which option is matching? Option number D. This option is the option. Okay, this is the correct option. Next question, question number 5. Okay, we are going to solve question number 5. Okay, let me just check. I'm just taking out the question. It's taking time. This question is going to be question which is asked in IIT-Jam. Okay. Question number 5 is this. Okay, this one. This is the question which is asked in 2019. This is IIT-Jam 2019 question. Okay. So this is a unit vector. Question is a unit vector perpendicular to the plane containing A equal to I cap containing vector A equal to I cap plus j cap minus 2k cap and B equal to 2 I cap minus j cap plus k cap is. Okay. Options are 1 upon root 26, 1 upon root 26 minus I cap plus 5 j cap minus 3 k cap. Option B is 1 upon root 19 minus I cap plus 3 j cap minus 3 k cap. Option C is 1 upon root 35 minus I cap plus 5 j cap minus 3 k cap. Option C is 1 upon root 35 minus I cap minus 5. Option D, 5 j cap minus 3 k cap. Okay. So this is the question. The question is a unit vector. You need to find out a unit vector perpendicular to the plane containing vector A and B. So there's a plane which contains two vectors A and B. So we need to find a unit vector which is perpendicular to these vectors, and these vectors are in the plane. Okay. So that's what we need to find out. Okay. So this is a good question. So I'm going to solve it here. Okay. So here we are going to solve it by the options. Okay, because uh, unit vector which is perpendicular to these two vectors, it means the The dot product of unit vector and this vector is going to be 0 because unit vector means cos 90, right? That is 0. So it means, suppose there's a unit vector, you can say n dot a vector is going to be 0, should be 0, and n cap dot b vector should be 0 because n vector is perpendicular to these two vectors, and dot product is any cos theta, right? Cos theta is 90, it means their dot product should be 0. So we'll check option by option. Okay, so I'm going to check with option D. So option D, let n cap is, so let we say n cap is 1 upon root 35 minus I cap minus 5 j cap minus 3 k cap, 3 k cap. Okay, so we'll find out n cap dot a cap. This is going to be 1 upon root 35 minus I cap minus 5 j cap minus 3 k cap dot a cap. What is the a cap? Sorry, dot a vector. Okay, a vector. What is a is given here? This is I cap plus j cap minus 2 k cap. Okay, this is dot product and this will find out. So this is going to be 1 upon root 35. So it is going to be minus 1 minus 5 and plus 6. Okay, so this is going to be 0. Similarly, we'll find n cap dot b cap, right? This is going to be 1 upon root 35 minus I cap minus 5 j cap minus 3 k. We are solving this by option. Okay, we have taken option D as a unit vector. Okay, and what is the vector b? 2 I cap minus j cap, 2 I cap minus j cap plus k cap. Okay, so this is going to be 1 upon root 35 into minus 2, okay, minus plus 5 and minus 3. Okay, so this is also going to be 0. Means, so the correct option is D because D is n cap, because this so if you are making dot product of n cap with a and b, this is giving 0. So n cap dot is 0, or n cap dot vector a is 0 and n cap dot vector b is 0, right? This is vector a and this is vector b. So means option D is the correct option. Okay, this one, I cap minus 5 j cap minus 3 k cap. Okay, so this is the answer. Okay, well guys, I will stop here, and I would request the people who have not subscribed my channel yet, please subscribe my channel, and thank you so much for watching the video, guys, and good night, bye now.